Okay, so again, this is session 4 covering patient monitors and pulse oximetry. I want to start with a little bit of introduction. Again, we're recording this session so that everybody who's here can review later and also send it on to your friends and colleagues who need the same information. Echo etiquette for those of you who are new. Today we're going to talk about patient monitors, pulse oximeters in a very technical way. The foundation of our conversation is love and respect. Please make sure you're responding kindly rather than reacting. Go ahead and test your equipment ahead of time when you can. Be sure to mute your microphone when you're not speaking. It's in the bottom left-hand corner of your screen. And if you are going to speak during discussion, make sure you unmute yourself and also introduce yourself to the group. Speak clearly. If you're in a large room, stay close to your microphone. And if you have any IT issues throughout, you can chat us here or email us at assisthtm@assistinternational.org. Today, again, we're going to do a short didactic about patient monitors. Guna will also go through the preventive maintenance on patient monitors using some materials gathered from our team in Musoma, Tanzania. And then we'll open things up for discussion at the end. You can feel free to track your questions in the chat or write them down and we can call on you to share. A brief summary of our very first session, because PPE and disinfection are so important. This virus, COVID-19, is stable on plastic and stainless steel for up to 3 days. It's a very long time, and that's what a lot of our hospital equipment and hospital surfaces are made of. So how do we keep ourselves and our equipment safe? We use PPEs as described. We also continue to use hand hygiene and things like that despite PPEs, just to make sure we're being safe. And then when we're cleaning equipment and environments, we use high-level disinfectants like those listed on the right. In summary, everyone should practice basic hygiene and social distancing. If you're in a hospital setting, you should also increase frequency of things like basic hand hygiene, increased use of protective equipment, and also increased frequency of equipment disinfection. Again, the virus can last up to 3 days on some surfaces, so stay safe out there. If you need some more resources, specifically on specifications for equipment and supplies, you can use this link here. We'll send out the slides and the recording afterwards. You may have noticed that the recording for last week was not full and complete, so we linked to the Africa section on the same topic. Today we're going to talk about patient monitors. Specifically, we're going to talk about how to perform preventive maintenance on patient monitors. We'll also discuss basic troubleshooting, and also maintenance, and also proper disinfection between patients. And with that, I will turn it over to Guna, and you can take it from here.
Hi, everyone. So, patient monitor is basically, we're going to a medical device that measure ECG, heart rate, NIBP, IBP, SpO2, oxygen saturation, and CO2 and CO2 temperature, all this. Okay, this is specification given by WHO for patient monitor. So it's generally when you want to purchase patient monitor, you need to know what's the specification. So this is part of it that you can look into it actually. So for ECG details, then NIBP details, all that. Pulse oximeter, temperature, respiratory CO2 and power supply requirement, all that. Then the standards, things that you need to know, the configuration of it. Okay, this part we're going to talk about, main part of the function of the patient monitor. So basically very important, we're going to talk about ECG. ECG is a part where you record your waveform of your electrical activity on your heart, fast rate and span of heart rate, all this. So these are one of the important parameters that you always see in patient monitors. So this is basically a normal ECG waveform, a PQRS sequence in ECG that you always see on the patient monitor on the display. And this is basically the duration, everything, the details, breakup of the PQRS details. So this is type of details, QRS complex, all that. Then Einthoven triangle is basically about placing your leads on your body, patient body, all this. It's quite important actually to know this. So standard electrode placement is right arm, left leg, or near to the body. So lower, front, rib, all that. Color code ECG, everyone knows there's two standards are being used, IEC and AHA code, American standards. So these are basically two type of color code that you normally see on your patient monitor. Sometimes you are maybe going to see only IC standard, some of it AHA standard. So you need to know this particular thing when you working on your PM, preventive maintenance. ECG block diagram is basically we're going to talk about the block diagram of high pass filter, low pass filter, how it works. Basically, when you getting a signal, you need to amplify. IA is basically isolation. From there, you're going to go to high pass filter, then amplification, all that. So to balance up the signal and to cut down all the distortion level, and eventually you transmit the signal to digitalize on the screen. So this is basic things that you're going to see on patient monitor. Normally you're going to set on the lead 2, and that's the reference point of your ECG. And the heart rate you're going to monitor, and you got low alarm and high alarm setting, and your heart rate reading. If you go to low alarm, it's going to alarm. Above high rate reading is going to alarm. So when you're doing ECG, basically one of the important part is to prep patient, basically to prepare the patient on ECG. This is one of the common problem that you're going to deal with user, because what happens is you're going to end up seeing electrode, expired electrode, sometimes not enough ECG gel, sometimes ended up the ECG electrode being used more than 24 hours. All this can cause not a good reading. Sometimes you're not going to get any reading, or the reading is not stable. So all this you need to know, because if the ECG gel is dry or not enough, you're not going to capture any reading, or not, the reading is not good enough. This is very important. When you do preparing a patient with the ECG, this is part of the things that you need to know. Because sometimes user going to complain that ECG reading is not good, but eventually see maybe the ECG lead is overused or expired, or ended up maybe sometime you deal with the ECG gel, you are not putting the gel enough on the body. Respiratory and capnograph is basically one of the thing that you can see in two type of form. One is basically you are linked with the ECG. So the ECG system is basically going to measure between the electrodes, resistance, value of the skin, impedance. Based from that is going to give you a respiratory reading. That's with the ECG. And another method is ETCO2 that can calculate respiratory rate by driving out the carbon oxide going to the module. From the module is going to measure. That is more accurate compared to the ECG resistant impedance. So this is how the respiratory circuit electrical model look like that work for ECG. Temperature is one of the key factor because you need to measure temperature of the patient. So these are normally going to see on the most of the device with temperature 1 and temperature 2. So basically is attached to the skin, and you can monitor the temperature of the body, all that. Blood pressure. So you got two type of blood pressure monitoring. One is invasive type, another one is non-invasive. Non-invasive basically using cuff, and invasive is basically inserting a catheter line in the artery. So it's going to measure by using a pressure sensor. SpO2 is one of the important. Basically, you're going to monitor pulse oximeter saturation of the patient's body. So these are basically one of the part that you need to know and need to be maintained always. So one of the common problem you're going to see is the probe, all that. So always check this particular probe, keep it clean, all that. So that's not only patient monitor have pulse oximeter, but they have a standalone unit as well. Something like this on the picture that you can see. Some of it you can see a smaller unit that use on the finger, and you can see the display with the probe together. So that's a new one, that small units. But these are standalone units that you can purchase separately. So measuring SpO2 is basically non-invasive method. So they use by using a light sensor, source rate and infrared, and send the signal to your finger, and light signal from there is going to rebound and send to the photo light signals. So that's where it captures all the readings. So position of your SpO2 can place on your ears, baby's legs, fingers. These are very common place that you can do the position of the SpO2 sensors. So when you talk about working principle, you need to know the patient monitor overview. So basically you're going to see a screen with the display of ECG, respiration, SpO2, and NIBP, IBP if you are insert the patient with IBP connection, then ETCO2, all this you're going to see, and you're going to see all the connection at the front or at the side with the module, and you got high alarm, low alarm, display, everything, and with the light sequence, all that. So these are basically to monitor, and the temperature connection, all that depends on the model and brand, where it located on the probe connection. It can be at the front or at the side, all that. Some are touch screen, so it depends on the brand and the model. So at the back view of the patient monitor is basically you're going to see the real view of it. You're going to see air ventilation, equitation terminal. Depends if the equipment is class 1, you're going to see equitation terminal. If class 2, you're not, they don't have any particular terminal. So to justify class 1 or class 2 equipment for electrical safety, please look into the symbol of the particular logos for class 1 and class 2 at the back of the rear view of the patient monitor. Side view of the left panel or right panel, maybe you're going to see a thermal printer or USB connection or LAN connector for networking purpose. So basically you can do a centralized system, all that. So, and you're going to see RS-232 interface for upgrading the system, all this. So ETCO2, these are one of the Untitled CO2 connector that normally you're going to see side stream or mainstream, depends on the spec that you're going to see. you're going to purchase. Depends on the brand as well. But these are very common filter line with the water trap, all that. You're going to see the water trap normally located near to the patient monitor. So whatever EtCO2 tidal wall reading is captured, and all the moisture is going to capture on, going to stuck on the water trap. So water trap need to be replaced. Temperature, these are how the temperature probe look like. It's very common. I think all the patient monitor is almost similar with the connector can be 6.5 mm connector, or some of it, they got their own connectors. Non-invasive blood pressure is basically NIBP, and these are one of the very common thing you're going to see with the cuff and with the tubing, all that, and the reading going to be the mean reading, systolic, diastolic, all this. Invasive blood pressure is basically one of the most accurate, that you're going to go through the catheter line and all that. So it's going to use high sensor, so like pressure sensor, more accurate, and is going to capture directly on your line. So these are comparison between blood pressure, NIBP and IBP. So these are how the signal look like when you use to monitor on the patient. So these are basically sensors that you're going to see in NIBP and IBP as well. You got differential and absolute sensor, all that. This is one of the fiber optic pressure sensor. This is one of the type that they can use to measure the pressure. And more accurate is MEMS, is micro lateral mechanical system, is more accurate and high quality pressure measurement. So this is depends on the patient monitor that you're going to see. Sometimes they're going to use this as one of the important part. So this is blood pressure accessories for IBP. So normally what you need is infusion set, tube, three-way, connector, holder, and transducer, membrane sensor, and dome diaphragm. These are one of the common accessories used in IBP. Okay, patient monitor preventive maintenance. This is one of the main important topics. So as usual, why preventive maintenance is important? To reduce risk of injury to the patient, staff, visitor, and even the BMAT itself. So these are very important part of it. So to increase the life cycle of the patient monitor and decrease the cost of the particular equipment on maintenance. So reduce the operational difficulty. So what happens is, if your NIBP curve is not good, you have difficulty to use it. So by doing preventive maintenance and all this checking, you know when exactly need to be replaced. So the operation of the particular unit can be constantly and easier. So when you talk about preventive maintenance, you are talking about quality tasks like physical inspections, all this, visible tests and cleaning, then electrical safety tests on the system, and performance of verification tests. You're performing testing the parameter of each function like ECG, SpO2, all this, whether it's working properly or not. To do that, you need to do certain things like cleaning. First thing, one of the important part of it. So basically you clean the sensor, everything, to make sure it's clean, all that. So during the testing will be easier. And safety tests and functional check. So you need to check most of the patient monitor, they come with the battery, all that. So you need to check the battery, whether it's working properly or not. Try to discharge and charge the particular battery to check whether it's working properly or not. So electrical safety is one of the important part of it. If class 1, you have to do protective earth tests, then you need to do earth leakage current, all this, then patient apply part, all this. This is one of the important tests that you're going to do according to the standard 60601 or 62353. So this is standard checklist that you're going to see for patient monitor. Then this is method of doing by using the electrical safety analyzer. So performance test. When you talk about performance test, is basically you are doing to test according to the standard guideline. So you're going to measure ECG, all these, SpO2, NIBP, whether it's inside the particular range or not. So the test tool that you need normally when you do performance tests and electrical safety, you need patient simulator, then SpO2, then electrical safety. All these basically electrical safety are used to test electrical safety of the equipment. Then for performance, you need to use patient simulator to check ECG, NIBP, IBP, and SpO2 for check SpO2 simulation. System test is basically when you're on the particular device, it's something like a self-test. So it's going to check whether the system is working properly or not. But at the same time, a system test can be done by using the service menu, but you need to have a certain service access. So you need to have some password. Depends on the brand and model. Sometimes maybe you have some brand of it, so you can enter this particular setup and check the particular system test. So patient monitor are normally always you have ECG, respiratory, NIBP, and IBP in the particular thing. But by using this patient simulator, you can monitor NIBP. These are SimCube unit, so you can measure NIBP. IBP, you need to have special connector for that. Respiratory and ECG are working together. Basically, what happens is when you run the ECG, respiratory will work together. That's a reading setup such a way. So when you set 70, the respiratory will be 20, 70, ECG 20 on respiratory. So this is patient simulator part. So these are basically ECG connection, button type, so to connect all these particular things. So 10 particular leads are connected here to measure the 12 lead. SpO2 simulator, I use to measure SpO2 sensor output. So you simulate the reading, for example, 99% of saturation and heart rate maybe 85. So by setting that particular reading, you're going to verify whether on the patient monitor getting the same reading or not.
Hey guys, I just realized that my screen is not showing very well because my internet is a bit unstable, so I'm just gonna reset real quick. So sorry.
No problem.
All right, I think we were on the LCD test.
Yep.
All right, Carry on, Guna. Sorry about that.
No worries. So LCD test is basically the test that you're going to do, like color screen testing. So these are on the test mode itself. When you're on, sometimes the particular patient monitor going to do LCD test itself. Some of it you can go through the service mode. If you have password, you can do LCD test by using the service mode as well. If you don't have, when you power up, the LCD test is done at the same time actually normally. Alarm and audible test is basically work during your PM. So when you do ECG, all these, you're going to see high alarm and low alarm. All these basically are being monitored. So when your ECG setting is lower than particular set point, it's going to alarm. When the ECG reading is higher than the set point, it's going to alarm as well. So this is one of the normal tests that we do during PM. So pass and fail results depends on your checklist. If your checklist reading is compile everything and everything is passed, you can put pass there. Battery check is basically check the battery by removing the power cord, see whether from the incoming power it transfer to the DC mode or not, to the battery mode. If not working, please check the battery and try to charge overnight and check if it works. But normally most of the recommendation is 2 years. Every 2 years you need to change battery, so better follow the recommendation, because normally the lifespan of the battery will be shorter, and the way you use your particular patient monitor also play a very important role on your battery. So this is basically performance test report. So you can see all the parameters that you're going to measure. Some of it you can skip, like temperature if you don't have a proper probe, and NIBP if you don't have proper probe, you can skip them. But normally you need to do most of it. If you got all the probes, better to do everything. So NIBP test mode, these are basically you're going to see on the SimCube unit. So you're going to see adult, neonate, high, low, all these are basically NIBP simulation, and you got manometer, leak test, all this. So NIBP simulation configuration is basically when you talk about dynamic simulation, you're going to simulate a patient condition on the patient monitor. For static, is basically you're going to calibrate the pressure, or sometime you're going to do a leakage test. You need to use this particular configuration. So this is an NIBP analyzer with a configuration of dynamic to check the simulation of the NIBP. Leak test is one of the key things that you're going to see on the patient monitor. So leak test, basically you need to have service mode to do this, to lock the particular pneumatic valve inside the patient monitor. So you need to go to a service mode. If you don't have this, you can avoid this particular test, because if your simulation is fast, leak test normally it's not that so important, because simulation reading is good. Troubleshooting. So when you talk about patient monitor troubleshooting, it's very common. The first thing is battery is a very common problem. So you need to discharge the battery and recharge the battery and check if the battery works properly or not. If it is not working, you need to replace, So normally you need to know the part number of the battery and the part number of replacement of the board as well. If the battery is working properly, but the charging circuit is not working when you exchange the battery to another patient monitor, that means you need to replace the charging board as well. So what do I do if the monitor won't turn on? So normally when you won't turn on, you check the battery first and check the power supply and check the AC control board. These are very common problem. So normally always remember part number play a very important role when you want to buy a parts. So LCD, one of the common problem that we can see. Normally the display is not working properly or blank screen. So you need to replace the display. When you power up, it doesn't on, but the power is coming in. So that's another method of things that you need to know how to check the LCD. When you power up, the power supply is working properly, but no display. But you can hear all the sounds, all that. That means something wrong with the display. But the display can be connected with the main board. Sometimes the main board also can give problem. So the best thing is to compare this particular unit with another unit, or get the part number of these two units. Maybe get the LCD display first and replace. But it depends on the condition. But some of it, the main board also can be a problem. So just careful when you change this particular part. ECG, normally you don't have any problem with the connector, internal connector, and ECG board, normally you don't see much problem. The common problem that you're going to see on ECG is basically the accessory, the ECG cable itself. So just cross-check with the cable by using the ECG simulator. If it doesn't work, get another accessory, ECG accessory, exchange, and try with the simulator again. It works. That means the accessory is the problem, not the internal part of it. Okay, what do I do if the NIBP accessory is malfunction? So, normally you ensure the cuff and the hose are used correctly with the patient, and check the connection between NIBP module and patient monitor. Check the NIBP module. If the module is defect, replace or repair the NIBP module. To check the NIBP module, if you got same model, maybe you can cross-exchange and test it out. So what can cause inaccurate results on automated BP units? So these are very common things: incorrect cuff size, incorrect cuff application, wrong cuff size, all this. Then irregular heart rate, rapid change in pressure, patient movement, and placement of cuff not at the heart level. So all these are very common things that you're going to see. Okay, troubleshooting by using error code. So these are based on well-challenged error code. C02 is auto, zero failure, all these. These are code used by well-challenged. Each brand and model, they got their own error code. So remember, you need to open your service manual or user manual to troubleshoot sometimes. So for SpO2 module malfunction, normally you're going to check the SpO2 sensor. If the SpO2 sensor isn't on, the red light you cannot see, replace the sensor. So these are one of the very common problems that you're going to see in SpO2. Another way of doing it by using the SpO2 simulator, verify the probe whether it's working properly or not. If still if the probe is working and you replace with another probe and the patient monitor still cannot capture the SpO2, that means something wrong with the main board, with the SpO2 board or the main board. So typical error breakdown, common problem, you're going to see sometimes displays, but most of the time I'm going to see in Cambodia or in most of the country is the power supply problem and battery problem. Some of it accessories. These are very common problem that you're going to see. Chances of board failure is quite less, but these the three symptoms that I'm always seeing in these type of countries, like power supply, battery, and accessories. So these are how the system processing look like. Inside the block diagram, basically you're going to see power supply and printing unit, sound unit, processing unit, then ECG, IBP, SpO2 are in a separate block diagram. Okay, simple scenario. Okay, if the user report that BP monitor is faulty, what can be the cause of this? Okay, so I'm asking you guys back, if monitor does not turn on, so what may be the problem? Can anyone explain this particular part of it? So this is the scenario that the user are facing. Anyone can explain this? So this is part of the discussion that we can talk about. Number one, monitor does not turn on. So what's probably the problem?
Good morning, Gona. I'm Madi from Kapot Hospital.
Yeah,
I think, yeah, if monitor does not turn on, I think because of the power cord. We can.
One.
Yeah.
Okay, what else? Anyone else? Thanks, Madi.
Yeah.
Good morning, Gona. I'm from Medigroup.
Yep.
Yeah, for me, I think that it can be from power supply or main board. Yeah.
Okay. Anyone else? Thank you, Medigroup. Okay, for the second one, monitor turn on, but there's no response when start is pressed on NIBP. Second question. Anyone?
Hi, Gona. I think that it can be from the NIBP pump does not work.
Okay.
Hi, Guna.
Yep.
Guna, it's me.
Wow.
Yeah, right. How are you, bro?
Yep. So the second question, what's the answer?
I have maybe a troubleshooting too when the switch is working, but maybe the motor pump maybe fail or flash valve is fail too.
Okay. So correct. Okay. The third one. Anyone else? Before we go to the third one.
Không xin.
Okay, the third one, device is start cycle, but the cuff will not inflate. Anyone? The third one.
Maybe Guna.
Yep. Anyone? The third one?
Hi, Gonna. I think it's may leaking somewhere.
Okay. Anyone else? Thank you all.
I think the cuff is not have air leaking, maybe connector not properly. Guna.
Okay.
Or
Can be
cuff
also.
they mean leaking from the cuff, right?
Okay.
Or connector, yeah. That's all.
Anyone else? Madi? Anyone?
Yes, for me, I think that the same because of the leakage system or cap loose or anything leakage
Okay.
in the system of the NIBP. Yeah.
Okay, let's go to number 4. Cuff inflate, but then does not deflate and the machine alarms. Anyone? Question number 4. Anyone? And that's the scenario, number 4.
Hi, Gonna. I think that is the problem from the cuff that they use is not properly. It's like they use the cuff for adult, but they use for the pediatric. That's why the result is still high or low.
So is the sizing, sizing of the cuff.
Yes, the sizing of the cuff.
Okay. Anyone else? Anyone else? Before we go to the final one, number 5. 5th question. So let us go to the number 5. The monitor is frequently giving NIBP reading. So what do y'all think about this? What's maybe the cause of the problem?
Maybe leaking.
Okay.
Yeah.
Anyone else? It's giving reading, NIBP reading. Is it leaking?
Leaking. Because the motor still pumping, right? But the leaking.
But normally when it leaks, it's not going to give any high NIBP reading, right?
Yeah.
So anyone else? Ong? Wah?
Hi, Gonna. Let me answer for the question for number 4.
Yeah.
Yes, the number 4 is because of the cuff is leaking.
Number 5.
No problem, no problem.
Yeah. The number 4, I think that the cuff is leaking. When the cuff is leaking, the pump motor it will try to pump and pump to reach the target, and the cuff is still leaking, so it will be error. And the number 5 is that the cuff, because the cuff size.
Okay. Yep. So number 4 is correct. When your cuff there's some sort of leaking, the particular cuff try to keep on pumping and pumping. Eventually, it cannot give you a reading, and it start to give an error code with the machine alarm. Number 5 is cuff sizing. So your size is wrong. You ended up going to get eye reading. Sometimes your body movement, all that, you're going to give eye reading or low reading. It depends on the cuffs also. So most of y'all got it right. So these are scenario that you're going to see with the user. Okay, thanks, man. So the next one, we're going to discuss about maintenance of patient monitor. So these are done in Tanzania. So basically, understanding the procedure of preventive maintenance of the patient monitor. So we're going to talk about how to do preventive maintenance by using all these test tools and all that. So I'm not going to explain much on that particular part of the function, but physical inspection, basically, you're going to check the housing of the patient monitor, casing, all the accessories, ECG, SpO2 cable, power cord, batteries, sensors, and probe connector. And at the same time, you have to do all the cleanings. So these are basically all the accessories that you're going to see on the patient monitor, like SpO2 sensor, power cord, temperature sensor, ECG cable, BP cuff, all this. BP cuff, you need to clean. Sometimes people are going to overuse it until the cuff cannot strap properly, all that. So you need to clean all that. Sometimes you need to replace the cuff. Physical inspection is basically a checklist that they use to check all the physical condition. So basically, Calmet using this checklist, a standard checklist that is used in Tanzania as well.
Me too,
So,
bro.
yeah, we're also using it. Huh? So electrical safety. So basically, you do electrical safety first. After physical, you do electrical safety. You check all the parameters of electrical test is passed, and you check the ECG cable, all that. So these are the electrical safety checklists look like. So you got so many readings, almost 21 tests there. For class 1 and class 2, the test can vary between 21 to 16 tests, and depends on the probes that you connecting. So these are electrical safety checklists. So when you do performance tests, is basically you're going to check the ECG rate, respiration, and NIBP, SpO2, temperature if you got a temperature testing connector, then IBP if you have a IBP testing probe, all that. So these are the performance test checklist look like. So basically all the parameters are there according to the SimCube checklist. This particular checklist follow to the SimCube performance test. So you can change this particular performance test according to your simulator as well. So you need to do low test, actual reading, then the eye test, and you check the alarm is working or not with ECG, respiratory, all that. Okay. So normally you're going to see problem caused by alarm is improper setting, probe connection is not connected properly, power supply is not because of the alarm, power supply can be due to the battery failure, all that. You're going to hear alarm for battery failure. Then hardware problem is basically caused by cables, circuit problem, display problem, failure of buttons, keypad, and battery drain. These are normally hardware problem that you're going to see. Software problem is basically due to power failure. Ended up the patient monitor itself have software problem and fail, cannot on all this. It doesn't reboot. This the usually normally things that you're going to see due to the power failure, all that. Then clinical user error is basically lack of knowledge and poor handling. So basically, they're going to drag the patient monitor with the probe cable, not the carrying the patient monitor. I've seen few places are doing this, all that. So awareness on the clinical user, basically, you guys as a biomed have to give the awareness or training how to use proper way and to make sure the probe lasts longer and the patient monitor are working properly. So this is one of the things that you need to do. So to keep the patient monitor work properly, you need to do proper handling and care. Basically the user, all that, you need to train them, do preventive maintenance on time by using test equipment. If you have all the test equipment, all that, do it in the proper way, doing calibration. Certain place you need to use UPS to avoid power, UPS or stabilizer to avoid power fluctuation. Provide enough knowledge training to the user. Ensure healthcare center have enough biomedical engineer and technician. These are very important. So as a biomedical engineer or technician, give awareness to the user and make sure the equipment are maintained. All right, guys.
All right, very cool. Thank you so much, Guna, for sharing. And if you guys want to see the original presentation from the Musoma BMATs, you can check out one of the links on our website, which I'll share shortly. So I think we have some questions in the chat. And again, we're going to open the floor for discussion. If you have any questions, any comments, any feedback, you're welcome to share. I'm also going to launch a poll, so you should see it pop up in just a second. So you can give us some feedback that way, just so we know what you're having trouble with as far as Zoom is concerned, as far as the content is concerned. And you can just keep us in the loop so that we can make sure our sessions are very relevant. With that, I'm going to turn to the chat and read out some questions. Back in the beginning, Hong from Metagroup asked if it's possible to go into more details about IBP as opposed to NIBP. Can you talk a little bit about the differences there?
Okay, IBP testing on the patient monitor, you need to have a right probe connection. That they normally the simulator have the standard connector, but at the same time, that's a special connector from the simulator to the patient monitor. So the special connector is normally according to the brand and the model. So if your brand is GE, you need to have a GE IBP connector that going to the simulator. That's normally you have to purchase from your and the simulator manufacturer itself, because the simulator manufacturer that particular connector according to the brand. Because IBP connector for GE, Philips, any other brand, the connectors are different. So to get this connector for IBP, you need to go to the manufacturer of the simulator. So normally what you do is you do the connection to from the simulator to the patient monitor, and you're going to measure this particular parameter of IBP. Basically, you need to do zeroing first. After you do zeroing on the patient monitor, then you start to change reading on the simulator, and you see the outcome of the reading. You set 100, you're going to see 100 on the patient monitor.
Thanks, Gunnar. I think the next question is also from Hung. The user always asks for what solution liquid you should be using on your LCD screens with patient monitors. Do you have any recommendations there?
I think we did went through this particular detail on the solution on the session 1, but I can highlight that particular thing that we can use.
Yeah, and I think the key there was not to use alcohol solutions on LCD screens, correct?
Yep.
This is the
Correct.
bubble.
Yeah, we did spoke about this. I think we need to use a normal solution and a damp cloth on the LCD screen to clean them, but you need to power off, let the patient monitor warm down, all that, so the lifespan of the LCD can be maintained.
And if you want more information on disinfection of all equipment types, you can take a look at the very first session we did. I just put a in the chat. It's assistinternational.org/COVID-19 resources. And then you can view this session as well as all the others so far. Get a few more details. Are there any other questions? We've still got a couple minutes before we wrap up. Okay. Well, if that's the case, then thank you again for joining us. We're very grateful that you've all been here. Stay safe at work. Be sure you're being careful and using your PPEs, and we'll see you again same time next week. Thanks, everybody.